interiors, but for many things, I guess you can only learn by actually making them.
Yes, you learn as you go. So we can see that they're trying to make Shinkansen interiors more inviting. Dr. Nagase, how do Japan's Shinkansen compare in comfort to high-speed trains elsewhere?
Well, I don't much care to admit it, but ours are not really as comfortable as the French TGV trains.
Really?
But the reason for that isn't laxity on Japan's part. The infrastructure situation over in France is different. They have a really extremely rock-solid track system, so their trains can be pulled by engines.
They use engines to pull the coaches.
Yes, so all the power comes from in front. Japan's case is different. Our Shinkansen trains are designed to operate as economically as possible. Our tracks are much less sturdy than those in France. And that's why each car has its own motor.
To distribute the forces on the track.
Yes, and that causes more noise than with cars pulled by an engine.
Noise from below.
I rode on the French TGV last year, and I must say, you can't even call it a passenger compartment. It's more like a lounge. It makes long trips very comfortable. The seats are extremely plush, too. I'd be glad if Japan's Shinkansen matched France's for comfort.
Well, so much for comfort on the French TGV, but now let's talk about speed and the world's fastest train. Here are the speed records for wheeled trains, that is, not including maglevs. Now, last year, a French TGV reached an incredible 574 kilometers an hour. Of course, that was on a test run, but the TGV also holds the record for normal operations, 320 kilometers an hour.
That sure is fast.
And France has plans in the pipeline to raise that to 360 kilometers an hour.
But why did the French see the need to go all the way up to 570 kilometers an hour?
Well, the answer is competition. From about 5 years ago, the French have been involved in a fierce battle with the Germans over constructing high-speed railways. And so they are pushing the building of high-speed rail networks as a matter of national transport strategy. Faster trains and new speed records provide valuable PR coverage throughout Europe for whoever is claiming to have the best national rail system. And there's a trade advantage to be had as well. They are also seeking to export their technology and extend their high-speed rail systems into other countries. In Europe today, it's harking back to the era of the Roman Empire, when all roads led to Rome, as they say. Today's version is not about Rome anymore, but about Paris. All roads lead to Paris is the theme, at least in the minds of France's political leaders. But everyone can see that they have an excellent rail system, so why not?
So there is a battle for railroad supremacy in Europe, and the French are leading the way.
Yes. When you put it like that, their efforts make plenty of sense.
And Japan is not in the battle to top the 500 and some kilometers an hour, right?
Well, at present we have no reason to take part in that battle, so Japanese research is directed towards something more relevant to today's needs, achieving the highest commercially practical speed. It's a different philosophy.
And our next topic is actually concerned with an obstacle to raising operating speeds in Japan.
Right, reducing environmental impacts.
Here's a hint for you. Now, earlier we talked about the duckbill face of the Fastek, and that is officially called the arrow line shape. But the Fastek has another face too.
That's right.
And here it is. Now, this one is called the streamline face. You would expect the two ends of one single Fastek train to have the same shape, but in fact they are different.
Well, that way two different designs can be tested on a single train. Great idea.
Yes, it is. This streamlined shape is really sleek, and it looks very fast too.
So, two faces. What's the reasoning here? When a bullet train enters a tunnel, intense noise and vibration exit the far end of the tunnel ahead of the train itself. This combination of noise and vibration is called a static pressure wave, and it must be counteracted. How is a static pressure wave created? This is a 100th scale recreation of a tunnel and train. It's used to create actual static pressure waves for research. The pipe serves as a model of a tunnel. A plastic model of the train is sent through the pipe at 200 kilometers an hour. The model train is launched by the device at the far end of the pipe and then exits through the near end. Confetti is placed at the exit of the pipe to make the airflow more visible. The